Well, let's look at something a little bit more different. Where do we start? We're gonna start with this question. Last time when we were doing this, we stopped on this cubic. We used the factor theorem to factor this, and that was the end of this. Let's look at question 9. It says find the domain. Do you know what domain means? What's domain? Domain means the possible x values the function can take, right?
Mm-hmm.
And we're assuming this is the real number system, unless specified. We won't do complex numbers, I don't think. So everything we do is going to be real numbers. So in this, look at this x. Can x be 0? Would y exist if x were to be 0?
Yes.
Yes, x can be 0. What can x not be? Is there a number that you can think of that cannot be x?
-5.
All right, let's try that. So -5 plus 5, that gives you a square root of 0, which is a 0. So it can be -5. Okay.
Mm-hmm.
What about -6 though? You're gonna get a negative number inside of a square root. So this you can't have this. So it cannot be -6. So that means that x there, it has to be -5 or above. If it's less than -5, even -5.1, then you'll get a negative inside a square root. And it can definitely be -5. Okay?
Okay.
So you can say this is the domain. -x has to be greater than -5. If you want to use the interval notation, you do a square bracket for -5 because it's inclusive, and it can be anything from -5 to infinity. On a number line, it'll look like this. So that's for a square root function, right? It can't have a negative number. What about b? B is simply x cubed. Is there a number that you can think of which x cannot be here? This one, can x be 10 or -10?
Yes.
Can it be both of these? Yeah,
Mm-hmm.
it can be. In fact, x cubed is something called a polynomial. Anything, x power anything, if you see in any form, that's a polynomial. It doesn't have any restrictions on the domain. So for b, x can be literally anything. There is no restriction. So you can say x is an element of real numbers. It can be anything. On the interval notation, it'll look like this. Okay? Because it's a polynomial.
Mm-hmm.
And even if you had something like -3x5 plus 4x4, whatever, it doesn't matter what else comes here. Because this is a polynomial, the domain is XER. There's no restrictions. What about C?
X can't be 1.
Yeah, that's right. X cannot be 1. But how do you write it? We're going to say XER, and then you can write a little colon there, semicolon, and then X cannot be 1. If you want the other notation, basically it can be anything from -infinity to +infinity, but it cannot be 1. So you gotta go from -infinity to 1. And then union, you gotta go from 1 to infinity, and that's gonna be the interval notation. What about D? Is there anything that D can't be?
Zero.
Yeah, that's it. The x cannot be 0. It can be anything except 0. What about E? E looks a little bit weird. How do we find the domain for E? Any ideas? Can it be 0? E? Yes, it
Yes.
can. Yeah, 0 is good. For E, what you need to do is you need to factor this. In fact, you need to factor the denominator to see what the restrictions are. Let's look at it. It's a quadratic trinomial. How do you factor it? How do you factor a quadratic with 3 terms?
You use math.
Yep. What does it multiply to?
6.
Nope. Half right. It's going to be -6.
Oh.
2 and a negative. The signs are important when you do this. So multiplies to -6, adds to -5. This is probably factorable. What are the numbers?
-3 and 2.
No, it's not, because -3 and -2 would multiply to +6, not -6. Anything else that multiplies to 6?
-6 and 1.
Yeah, -6 and 1 will do it. And then because the leading coefficient here is a 2, you can't write x minus 6, x plus 1. But if this wasn't there, yeah, you could have just written x minus 6, x plus 1. But this one, you kind of have to break the middle guy into the two numbers. So 5x becomes -6x plus x minus 3. What can you pull out from the first two terms?
2x.
Yep. What are you left with in a bracket if you pull out a 2x?
X minus 3.
Yes. From the next two terms, you can pull out a 1 because you can't pull anything out, and then you'll pull out a 1. So you'll get this in the denominator, okay? In the numerator, we had 6x. Now, can you see what x can't be? I'll give you one of them. X can't be 3. Because if x were to be a 3, you'll get a 0 in the denominator. What about from this guy? What can x not be? If x were to be a certain number, you'll get a 0 in that bracket. No, just set it equal to 0 and solve for x. 2x plus 1 equals 0. X is going to be -1/2. So that means x can't be -1/2, right? And
Mm-hmm.
that's going to be the answer, because if x is -1/2 here, you'll get a 0 in the denominator. F, they've already factored it for us. Can you tell me what x can't be? Just going to look at the denominators. Can x be 3?
Yes.
Yep. You usually don't look at the numerators. Like, we don't really care about the numerators. The only time we'll care about the numerator is if, like, you have the same term on top and on the bottom. And yeah, x would not, like, if there was an x minus 3 here, then yeah, x can't be 3. But this one is very simple. It's gonna be x
It can't be
be,
-2.
yeah, -2, +1, -5, and you're done. It can be anything else. And that is the domain. I'm gonna skip some of these. All right, let's jump into. So that was just a quick review of things we've done in the past, I guess. Domain range. Let's do something new. Even this one, I think we have done something like this, but you'll see soon enough. We're gonna run into things we've never seen before. This one says find, simplify this by rationalizing the denominator. So, like, we don't like having negative powers. We kind of did this when we were doing exponents. we always write powers positively. I mean, usually. Same idea here. We don't like having a square root in the denominator. So what we do is we get rid of it. How do you get rid of a square root in the denominator? You'll multiply the term, whatever you're working with, you'll multiply it with something called its conjugate. Now, what's a conjugate? Let's look at a quick example. If you had 1 over root 2, yeah, you'll multiply this by root 2 on the top, root 2 on the bottom. The conjugate of root 2 is itself. So you'll get 1 times root 2 on the top, which is just root 2, and then you get root 2 times root 2 on the bottom. Root 2 times root 2 is root 2 squared. The squared cancels out with the square root sign. You'll just get a 2 on the bottom, and we've rationalized the denominator. Good?
Mm-hmm.
So basically the trick is to just multiply it by something and it'll kill the denominator, the root in the denominator. But then it's not always going to be smooth sailing. Like for example, if you have something like 1 over square root of a minus b, right? The conjugate of square root of a minus b is square root of a, it's itself, like that. So if you do this, you're going to get a minus b over a minus b. So that one is also very similar to the root 2. Another case you could get is something like 1 over root a minus root b. You see this? Now there's a little bit of difference. Now that we have multiple roots going on, it's not the same root. So the conjugate of this guy, that's because they're different terms being separated by something in the middle. It's not going to be root a minus root b. It's going to be root a plus root b. Now why is it this one? It's because this allows us to use a difference of squares to kill both of these roots. On the numerator, you get root a plus root b, but in the denominator, you get root a times root a is root a squared, which is just a, minus root b times root b is root b squared, which is just b, and there we go. So if there's there's multiple things going on with the sign in the middle, the conjugate is going to be the same thing with the opposite sign. If this was a plus, the other one would be a minus. Okay, that's the idea behind it anyways. You'll get it. If you don't get it, you'll get it. It's pretty straightforward. Let's look at this one. We have 3 over 4 root 5, right? The 3 over 4, we don't really care about it. We do care about the root 5. What's the conjugate of root 5?
Root 5.
Yeah, we'll just multiply this by root 5. So on the top, you get 3 times root 5, which is 3 root 5. On the bottom, what do you get?
4 times 5.
Yeah, which is 20, and you're done. Okay, easy as that.
Mm-hmm.
It's going to get progressively more difficult like it always does. Okay, this one. What is the conjugate of this denominator?
Root 6 minus root 3.
Yeah, root 6 minus root 3. So you'll multiply that on the bottom and on the top, and you can do this because this guy just cancels out to 1. So we're basically multiplying by a 1. And that's why we were allowed to add in on the top and on the bottom. So on the top, you'll get 2. I mean, you can open this bracket if you want. You'll get 2 root 6 minus 2 root 3. What do you get on the bottom?
Do you get root 6 plus root 3?
Oh, no, we're just going to use a difference of squares. Look at this. Root 6 times root 6 is root 6 squared, right?
Mm-hmm.
And this cancels out with this. You'll get a 6. And then this is a different, it's in the form of a plus b, a minus b. It's going to be a squared minus b squared 3. And 6 minus 3 is just simply a 3, and you're done.
Okay.
Okay, what about this one? What do we multiply it by? What's the conjugate?
Root 6.
So we just multiply by root 6? Like that? So if you see, when you multiply 3 and root 6, you'll still get a root. So that doesn't actually help us. It's not going to be root 6. When there's multiple things going on, you need to make it a difference of squares, okay? So all you do is you multiply this with root 6, or in fact, a plus b, you want to multiply this with a minus b. So 2 root 6 minus 3 and 2 root 6 minus 3, which will give us 10 root 6 minus 15 on the top. What do we get on the bottom? It's in the form of a minus b, a plus b. So we have a, right? A is 2 root 6. So we're going to square this. This squared applies to both the 2 and the root 6. What's 2 squared?
4.
4. And then what's root 6 squared?
6.
Yeah, so we get 4 times 6 for the a squared. And then we have minus b is 3, b squared, 3 squared, like that. And that's 24 minus 9. That's going to be a 15, okay? Like that.
Okay.
And we're done. So yeah, when there's multiple terms, you have to kind of look at it in terms of a minus b, a plus b. Otherwise, the root is not going to go away. What you can do, one extra step here is on the top, you can pull out a 5. You'll be left with 2 root 6 minus 3. And there's a 15 on the bottom. And 55 goes into 15 3 times, and that's the answer that they have. So they just kind of reduced it a bit. Okay, here, this one's asking us to rationalize the numerator. This one's pretty straightforward. What's the conjugate? It's the conjugate of the numerator there.
Root 7 plus root 3.
Yeah, that's it, right? Root 7 plus root 3, and then root 7 plus root 3 on the bottom. On the top, you're going to get a squared, which is going to be 7, minus root 3 squared, which is going to be a 3. And on the bottom, you have 2 times root 7 plus root 3. 7 minus 3 is a 4, and 2 goes into 4 twice. And there you go. That's going to be your final answer. Okay? It's not that bad. Let's try doing this one. This one looks a little bit interesting. Here, look at A. It says rationalize the denominator. Ooh, so what's the conjugate in A?
Root 20 plus root 18.
Yep. So root 20 plus root 18. Root 20 plus root 18. So if you do this, you're going to get 8 root 2 times root 20 plus root 18 on the top. What do you get on the bottom?
20 minus 18.
Yeah, which is simply A2, right?
Mm-hmm.
B is very similar. I'm gonna try and show you how to simplify this actually. Root 20, if you look at root 20, this is the same thing as 4 times 5 inside of a root. what you can do is you can split them apart into multiple roots. So it's going to be root 4 times root 5. And then square root of 4 is a 2, so 2 root 5. Root 20 is the same thing as 2 root 5, okay? And then for 18, it's the same idea. What is the biggest square number that multiplies into 18? A square number is a number squared. For example, 4, 1 squared is a 1, so that doesn't count. 2 squared is 4, that counts. 9, 16, 25, 36. These are the square numbers. What's the biggest one that goes into 18?
9.
9, right? So root 18, you can rewrite this as 9 times 2. And then again, you split this apart, you're going to get 3 root 2. So root 18 is the same thing as 3 root 2, okay? Like that. So that's the answer to part C. It says, why are the answers in part A and B the same? Because there's the same terms. Root 20 is 2 root 5, as shown here. Same thing with root 18 and 3 root 2 is shown here. All right, let's do these guys. These guys are going to be fun. Look at the first one. And now here we're trying to rationalize the numerator. We don't care about the denominator. What do we multiply the first one by?
Root A.
Root A is not going to help you. It's because, look at this, root A. The first one will cancel out for sure because A times root A is A, but then you're left with 2 root A. So that didn't help us rationalize the numerator. What's the conjugate of root A minus 2? Think about it like difference of squares.
Root A plus 2.
Yep. What do we get on the top?
A minus 2.
Not A minus 2. Try again.
A minus 4.
Yeah, A minus 4 on the bottom, you can just leave it as it is. And you're done. B, same idea. Think of it in terms of difference square. The conjugate is not root x plus 4. What's the conjugate of B? You have to think it in terms of difference of squares.
Root x plus 4 plus 2.
Yeah, that's it. Root x plus 4 plus 2 on the top, and on the bottom, well, on the bottom it's just going to be x times root x plus 4 plus 2. You can just leave it like this. On the top, we have a times a. That's going to be a squared, so that's going to be x plus 4. And then we have negative b times positive b, b squared. It's going to be minus b squared minus 4. This cancels out with this. Now you're only left with an x. That's going to cancel out with the x on the bottom. So the final answer is going to be 1 over root x plus 4 plus 2. Okay? Now look at b and c. B and c is the same thing. The only difference is there's an h on the top. So the answer to c is just going to be, actually it might be different. Let's do c. But it's very similar to b. The conjugate is going to be x, this guy, plus x. X plus h plus x. So on the top you get x plus h squared minus x squared. And on the bottom you'll get x times x plus h root plus x. A squared minus b squared. And this one you can't simplify. That's as far as you can go. Actually, a question for you. Can this x and this x, can we cancel them?
No.
Why not?
Because it's with the H.
Yeah, it has multiple terms. You can only cancel them if these guys weren't there, like how we saw in part B. But this one, that's as far as you can go. You cannot cancel out those x's. We're gonna move on to the next topic, which is slopes. There's two types. One of them is way more useful than the other. The first one is called the average rate of change. Rate of change is just a funny term for slope. But this one is the average. For example, let's say you have a curve. It doesn't apply to straight lines because straight lines, they have the same slope everywhere, so they're not that interesting. But when we look at curves or something, then it becomes a little bit more interesting. Let's say we pick this point on the curve and we pick this point on the curve, okay? And then we join them with a straight line. So the slope of this line is called the average rate of change. You can abbreviate it with IROC. Average rate of change. That's to find the slope between 2 points of a curve. And this line here, this line is called, it has a name. It's called a secant line. Mathematically, it's pretty easy. You're just finding rise over run. That's nothing fancy going on there. So that's the first kind, average rate of change. The other one is called, a little bit more interesting, instantaneous. Instantaneous rate of change, denoted by IROC. Now, what is this? This one gives you the slope at one specific time, or a specific x value. You see this point? Because this is a quadratic, this is x squared, right? The slope of this curve is different depending on the point you pick. Like down here, the slope is 0. Over here, you're going to get a negative slope. Over here, it's going to be close to -1. So the slope is going to be different everywhere. What the IROC gives you is it gives you the slope at one specific x value, which is usually time, like that. It's just going to slightly touch the curve at that point, and this line is going to be straight. It's a linear line. This line is called a tangent line. Okay? So real life applications, I guess. A secant line would be if you want to see the change, right? How it's changed. Maybe you throw, maybe, I don't know, what takes this shape. We can even flip this. Let's say you throw a rock in the air, right? Like that. And then you want to know its speed, its average speed from maybe the moment you threw it to 5 seconds. So you want to know what the average speed of the rock was between 1 second and 5 seconds. Whereas the instantaneous rate of change would be the rock's speed at maybe 3 seconds. So this gives you the slope, right? The speed is basically the slope or the rate of change. This gives you the slope at one specific time. Okay? One specific time. Whereas this one gives you the slope between 2 times. Between 2 times. Let's see what it looks like. So that's the idea behind it. It's actually not that difficult. Let's see what they give us. They do have a formula for this. Maybe it's not here. So I'll really quickly see how they do it. Okay. So this is the question. Determine the slope of the tangent to the graph at this point. Okay. So what do they want? let's say, what does this look like? It's x squared. 1, 2, 3. Let's say this is 3. Then that point there is going to be 9. And we're trying to find the slope of this line that just gently like touches that point. You understand the question?
Mm-hmm.
Now the thing is, how do you find the slope at that point? I'm going to show you first the dumb way of doing it, and then I'm going to show you, yeah, there's a bunch of ways to do this actually, and they're all pretty fun. What you need to do is you need to pick a point directly to the left or to the right of that on the x-axis. So we're looking at the x value of 3. What we do is we find what the y value is directly to the right or the left of 3. So I'm going to go ahead and find the y value when x is 3.01, so slightly to the right of that point. So f of x is x squared. That means f of 3.01 will be 3.01 squared. What is this? 3.01 squared. That's going to be 9.0601. Okay?
Mm-hmm.
Now think about it this way. Now we're just finding the slope. We have one point here. We have 3, 9. And then we have another point up here. And that point is 3.01 on the x and 9.0601 on the y, right? How do you find the slope between 2 points? This is a grade 8, 9 question. Slope between 2 points. You can just do rise over run. What's the rise from 9 to 9.0601? Well, you can just subtract 1 from the other. The rise is going to be 0.0601, right? This distance here,
Mm-hmm.
because we're going from 9 to this. And what about the run from 3 to 3.01? What's the run?
0.01.
Yeah, 0.01. That's going to be the slope. So 0.0601 divided by 0.01. The answer is 6.01. There you go. That's the slope. Doing it using this method, okay? You can also pick 2.99. You'll get the exact same answer or something very, very similar. That is not the way the book wants you to do it though. It does work. You'll see this way, done this way later. But there's an actual way of doing this, which is a little bit more complicated. Just keep in mind the answer was 6.01. Now let's look at the formula way of doing this. The formula for IROC, again, IROC, how do you know this is an IROC question? It's asking us for the slope of the tangent, which means it's IROC. And then they want the slope at one specific point, which also means IROC. The formula for IROC looks like this. It's going to be a little bit overwhelming. The IROC between at any point, at any specific point is this. The limit as h approaches 0 between f of x plus h minus f of x all over h. This part is not that important. You can kind of omit this if you would. Actually, you can't omit it. You can omit it in your head, but just write it on your paper. What does this mean? What's even going on here? You see how we picked 3.01, right?
Mm-hmm.
What we're actually doing is we're picking a number so small that we're calling it h. We're picking like 0.000001. Okay, that's what h is, and that's what this means. As h approaches 0 means we're picking a number that's very close to 0, but not quite there. Like think about like 0 point infinitely many zeros and a 1. That's what h is. It's a number that's almost 0. And then we're doing the same thing we did before, and then we're trying to find the slope between this point and and this point. When the x value is this, what's the y value? Now, how does this work? Let's do this question. So again, you just want to drop this limit thing. Eventually, this will go away. Step 1, f of x plus h, right? We know x is 3, yeah?
Mm-hmm.
So this is going to be f of 3 plus h minus f of x, which is 3, all over h. Now that h is 0, but it's not quite 0. That's why we're able to divide it. So the goal is to cancel this h out in the denominator by doing some algebra, and when that h cancels out, this limit thing also cancels out. Let's do this on the side. If f of x is x squared, what is f of 3?
9.
9, yeah, exactly. So limit as h approaches 0, h, f of 3 is just simply a 9, right? What about
Mm-hmm.
f of 3 plus h? That's a little bit trickier. Whatever you see in the bracket will be x. So just like how you replace the x with a 3 to get a 9, you replace the x with whatever's in the bracket, 3 plus h, like that. Okay?
Okay.
Like the same thing, like that. What's f of a? F of a would be a squared. What's f of a plus b? Well, it's going to be a plus b squared. Just replace that x with what's in this bracket.
Mm-hmm.
Now, what's 3 plus h squared? You can kind of do this in your head. If I want to FOIL it, if I want to expand it, what is it? There's a few ways to do that. What you can do is you can kind of like individually FOIL them. So 3 plus h squared just means 3 plus h times 3 plus h.
Mm-hmm.
And then you FOIL it like this. The first term is going to be 3 times 3, 9. The second term is going to be 3h. The third term is also going to be 3h. And the last term is going to be h squared. And you can add them as not a 9 plus 6h plus h squared, like that.
Okay.
Good?
Mm-hmm.
We're just foiling that, right? And then we're going to replace f of 3 plus h with 9 plus 6h plus h squared. Cool?
Uh-huh.
Now look at this. 9 minus 9 is a 0. You can ignore those two guys. In the numerator, what can we pull out? You see there's a GCF here that you can factor out. You can pull out an
An
h. Yeah. What are you left with if you pull out an h?
6 plus h.
Yep. And now look at this. This is always going to be the goal when we're doing like an IROC problem algebraically using this formula quotations. The goal, the main goal is to cancel out this h with the denominator h, like that.
Mm-hmm.
Once the denominator is gone, if there's any more h's left in the question, replace them with 0. So the answer to this question is going to be 6 plus 0. It's going to be 6. There you go. That's the exact answer. This one was an approximation because we picked 3.01, right? The difference was 0.1. If we picked 0.01, it will probably be 6.001 would be the answer. But that's an approximation, whereas doing it algebraically, this guy right here, 6 is the exact answer. Okay?
Okay.
thing is though, like we don't need to do any of this to find the answer, but this doesn't always work. What do I mean? This is the quickest way of doing it, and this is how I would do it. But the thing is, the question will ask you to use this approach, which is a little bit dumb, and this doesn't always work. That's also, I guess, why. Now, the third way of doing this, you see f of x is x squared, right?
Mm-hmm.
We're gonna find something called the derivative of this function. And it is super easy. The derivative is, what is the derivative? It's the slope function. Now, how do you find it? Well, like this. So f of x becomes f prime of x, okay? Equals, and you see this x squared? What you do is you bring the exponent, like we did with lns, like logs, you bring the exponent down here. And then you do -1 on the exponent. You first bring the exponent down here, and then you do -1. So it's gonna become 2x. Here's a few more examples. Like for example, if you had 3x3, this 3 would come in the front, so you have 3 times the 3 that was already there, x, and then you want to subtract 1 from the 3 up there too, so it becomes 9x squared. Okay?
Mm-hmm.
Bring that exponent down on the same level, and then take 1 away from the exponent, and that'll give you the derivative function. Now, what's the use of this? Well, once you find the derivative function, you literally plug in the x value to get the IROC. Boom. That's pretty powerful, right?
Mm-hmm.
But we can't use this. That's the thing. Like, you could use it. I mean, this is what I tell all my students. Use it, but don't write it on paper. Don't tell your teacher that you're using it. Do it in your head or do it on the side. Because they want you to use this, which I think is a little bit, yeah, it's a little bit annoying. But hey, this will teach you very good algebra skills, because this one was the simplest question. X squared is the easiest. When we go to like more higher level polynomials or even like a different function, things get difficult really quickly, which is where this is gonna come in handy. But yeah, they want you to use the definition. Let's do the next question. Use your calculator to graph the parabola. No one has a graphing calculator. What is this question? I actually, when I was in high school, we needed a graphing calculator because the math course was built around the calculator. It's kind of interesting. Basically, we would have multiple math exams of the same math course. We'll have 3 exams, and one of them was calculator, the other one was no calculator. And this calculator exam, yeah, so this kind of question would come up on that exam, where you had to know how to use your calculator pretty well. But we don't really need a calculator to plot this. We know a bunch of things around it. What are the x-intercepts of this quadratic? It's in the factored form. This quadratic is in the factored form. How do you get the x-intercepts?
-1 and 7.
Yeah, -1 and +7. We can also quickly find the y-intercept by plugging x as 0. So -1 divided by 8 times 1 times -7. The y-intercept is 7/8, which is like 0.9-ish. Is it opening up or down?
Um,
Opening up,
down.
down. Yeah, exactly, because the leading coefficient is negative. And then you just kind of plug the most artistic of drawing, but there you go. That's what it looks like, okay?
Okay.
And now what are we trying to do? We're trying to find the slope of the secant line. from -1 to 6. So when x is -1, we're right there, yeah? And when x is 6, looks like we're right there. And this line connecting the 2 points, that's the secant line, okay? Now the question is, how do you find the slope of the secant line? Well, it's just finding the slope between 2 points, right? It is just finding the slope between 2 points. When x is -1, y is 0. You can see that on the graph, right? When x is 6, what's the y value? Well, we simply are going to plug 6 in there. So 6 plus 1 times -1, -1 divided by 8 times 6 plus 1, 7, times 6 minus 7, -1. The answer is 7/8. Okay? What did we do? We just found f of 6, which is this point up here. That point is 6 comma 7/8. How do you find the slope between 2 points?
You subtract the x and y values.
Yeah, it's going to be rise over run. So the rise is going to be the y, so we have 7/8, and run is going to be 6 minus -1, like that, right? So 7 divided by 8 divided by 7, the answer is 1/8, and that's the slope of the secant line. Cool? We're literally just finding, secant is super easy. Secant is much easier than tangent, because it's just a linear equation, and you just find the slope. You don't even have to find the b value. Part C looks interesting though. It says use the result of part B to estimate the slope of the tangent at p 5, 1.5. So we want to find the slope of the tangent line up here when x value is 5. Right? Any ideas on how to do this? It's a little bit tricky, not gonna lie. It's just gonna be this thing. It's just asking us to estimate it, right? It's just gonna be literally this thing. And that's it. Okay? The estimate, because they're kind of close, they look similar. If they're asking us for the estimate, it's gonna be whatever we got here. And that is it for that question. Secant is usually a little bit easier than the tangent. And this is the tangent formula that we saw earlier. And let's look at this. This is going to be difficult. Well, it's not going to be, it's going to be like pretty rough algebraically. But I do like polynomials, so let's see how this works. So the formula for the slope of the tangent line, IROC, is limit as h goes to 0. And this thing just follows up until you cancel out the h's. F of x plus h minus f of x all over h. Okay? Part A. Find the slope at x equals 3. So we need to find a bunch of things here. First, we're going to find f of 3, because that's what the formula uses. To find f of 3, just plug the x as 3. So -3 squared plus 12 plus 1, 13 minus 9 is a 4. What about f of 3 plus h? What would that be in this case?
Where did you get the 12 plus 1?
I plugged x as 3. 4 times 3 is a 12
okay.
in the equation. That thing is our f of x in this case. You see, wherever you see an x, you're going to replace that with 3 plus h, like that, wherever you see an x. So there's multiple x's there. You've got to replace all those with what you see in the bracket. Okay?
Mm-hmm.
Like here, we replaced this x with a 3 and this x with a 3 to get a 4 at the end as the final answer. Same thing with the 3 plus h. Now, if you FOIL the first bracket, it's in the form of a plus b squared. Whenever you have in this form, it's always going to be a squared plus 2ab plus b squared. If you remember this, you don't have to FOIL it. It'll save you a lot of time over the years, which is what I'm going to use here. It's going to be 9 plus 6h plus h squared. If you open the next bracket, what do you get? No, we're just trying to open 4 times 3 plus h. 12 plus 4h plus 1. Okay. And then we have a negative here on the outside. That means everything in this bracket will be negative. So we have negative 9 minus 6h minus h squared plus, I guess, 13 plus 4h. Yeah. And then when we group up the like terms, negative 9 plus 13 is a 4. Negative 6x plus 4h is minus 2h and minus h squared, like that. Okay?
Okay.
We just, what did we do? This has nothing to do with this course. Just this bit here. We just opened the brackets, we FOILed it, and then we collected the like terms, right? And then you could have also absolutely done 3 plus h times 3 plus h and collected the like terms for the squared. But this saves us some time. And now what we're going to do is, again, limit as h goes to 0, right? H is going to be h on the bottom. What is f of x plus h? Well, in this case, it's f of 3 plus h because that's our x value. We just found it. It's going to be 4 minus 2h minus h squared minus f of x, which is f of 3 for us. It's going to be minus 4, like that. And that's going to be our setup. Now look at the beauty of this. We're almost done. 4 and 4 cancels out, right? 4 minus 4 is a 0. What do we do next? The goal is to cancel out that h on the bottom. Can we pull anything out in the numerator?
An h.
Yeah, you can pull out an h, so it becomes limit as h goes to 0. If you pull out an h, what are you left with?
Negative 2 minus h.
Yes. And now this is the part that we've been waiting for. This h and this h cancels out, okay? And if there's any more h's remaining in the question, they become a 0. So we have minus 2 minus 0. You don't need to write the limit thing anymore once the h's cancel out. And that's going to be minus 2 as the final answer. Cool. So there we go. This is finding the slope of the tangent. Now look at this. You don't need to do all this mumbo jumbo. You can use a shortcut. Now what's the shortcut? The shortcut has this thing. If you have a polynomial in this form, right? What you do is you bring the k down to the same level, and then you take 1 away from it. For example, like 5a4 becomes 4 times 5 times a cubed. Okay? Let's look at our function here. We have f of x or y, that's equals to negative x squared plus 4x plus 1. And for the one, it doesn't really have an x element. You can arbitrarily call it x to the power of 0 because that's still a 1. The first term, the 2 is going to come out on the front like this, and then you're going to take 1 away from it, like that. For the second term, the exponent of x is 1. That's going to come in the front. That's not going to change anything. And then you're going to take 1 away from it. You get x0. For the third term, you're going to pull the x in the front. and 0 times anything is a 0, like that, okay?
Okay.
What's x to the power 0?
1.
1, so you can ignore that. There you go, that's the derivative function. Negative 2x plus 4. And in this, what we do is we simply take our x value and we plug it in there. So negative 2 times 3 plus 4, negative 6 plus 4, negative 2, and there we go, we're done.
Mhm.
But that's the thing, they may not let you use this. For certainly they won't let you use this, but not yet. Eventually this is all we're going to be using. For now, they kind of want you to do it this way. And doing it this way is basically you're training your algebraic skills. That's what it is. And when it works out, it's fun. Sometimes it's not going to work out though. It's easy when it's a polynomial, but if it's something like sine of x or something, then we're kind of screwed. You'll see why next week, I guess. Let's call it for today.
All right. Thank you.
See ya.